Hi, I'm Tom Payne, presenting joint work with Chalar Gulchere and colleagues at DeepMind. I'll jump in. Many tasks are hard exploration, partially observable, and have diverse initial conditions, and there's not really a diagnostic suite of tasks that capture these properties in the literature. We created a suite of tasks with these properties and showed that state-of-the-art algorithms failed to see a single reward on these tasks after billions of steps. We introduced R2D3, which builds on top of recent advances in learning from demonstration and recurrent reinforcement learning agents, and show it can make efficient use of demonstrations to solve these difficult tasks. We call this collection of tasks the Hard 8 Task Suite. In each task, an agent, marked by a blue arrow, must interact with objects in its environment in order to gain access to a rewarding apple, marked by a red arrow. The 3D environment is procedurally generated so that every episode the state of the world, including object shapes, colors, and positions, are different, resulting in thousands of possible initial conditions. From the point of view of the agent, the environment is partially observed, both because it receives observations from an egocentric camera and because its view may be occluded by walls and objects. In addition, it may take hundreds of low-level actions to collect an apple and receive reward, which makes each task a difficult exploration problem. Each task requires a sequence of high-level steps to solve. For example, to solve the baseball task, the agent must find the bat, pick it up, use the bat to hit a ball off a plinth, pick up the ball, and use it to activate the sensor, which opens the door. Then the agent must walk through the door and collect the apple. Each step in this sequence must be completed in order and must be implemented by the agent as a sequence of low-level actions. There is no option structure available to the agent. The necessity of completing such a long sequence of high-level steps makes it unlikely that the task will ever be solved by random exploration. Note that each step involves interaction with physical objects in the environment, requiring the agent to deal with gravity and collisions. In order to solve these tasks, we developed an algorithm called R2D3, which stands for Recurrent Replay Distributed DQN from Demonstrations. The learner samples batches that are a mixture of demonstrations and the experiences the agent generates by interacting with the environment. The ratio between demos and agent experiences is a key hyperparameter, which must be carefully tuned to achieve good performance. Because our agent is recurrent, we must think carefully about how to deal with the trajectory sequences. We followed the approach of R2D2. See the paper for details. We compare the performance of R2D3 with several strong baselines on the Hard 8 task suite, including behavior cloning, deep Q learning from demonstrations, R2D2, and the performance of the human demonstrator. Note that several curves overlap exactly at zero reward for the full range of the plots. In contrast, R2D3 can perform human level or better on baseball, drawbridge, navigate cubes, and wall sensor. R2D2 could not get positive reward on any of the tasks. Each task has thousands of possible initial conditions, but R2D3 only makes use of 100 demos, not all of which are successful. In order to solve these tasks, then, the agent must generalize to initial conditions of the environment that are not present in the demonstrations. In the next few slides, we show qualitative results of R2D3 solving these tasks. Here we show the agent is able to fluidly complete the high-level steps required to solve the baseball task. In push blocks, the agent must navigate to the sensor, observe its color, find a block of matching color, and push it into the slot. In this episode, the block gets stuck, but after repeated attempts, the agent is able to get it unstuck and complete the task. In wall sensor stack, the demonstrators always stacked one block on top of the other in order to activate the sensor, open the door, and collect the apple. In contrast, the agent learning from these demonstrations found a bug in the environment which causes the sensor to stick, and the agent was able to exploit it to solve the task without stacking. Note none of the baseline agents were able to find this strategy. After fixing the bug and rerunning R2D3, the agent solved the task in the expected way. Thank you for listening. Please see the paper for more details.